All right, so today we're going to talk about just some more trig equations to solve. And today we're going to talk a little bit about what to do if you've got two different trig functions in an equation, and we can't really solve for one, right? So it's kind of like if we've got an equation like x plus y equals 5, right? Two variables in one equation we can't solve. Because what are you supposed to do? Get x by itself, get y by itself? Either way, you've got a variable on the other side, so it's not going to work. What you need in the case of that is another equation that have the same two variables in it. That way you can use them together in what's called a system, right, and solve them. And one method for solving a system is to get one of the variables by itself so that you can substitute in for the other one. So that's kind of what we're going to do with our stuff today, right? Now, in terms of needing a second equation to help us solve, we've already got those. We've got those in the form of trig identities. So we might need to use trig identities to help us solve, to help us take an equation that has two separate trig functions and get it down to where there's only one. That way we can solve it, right? For example, this equation right here, okay? Tangent squared plus secant squared equals 3. Tangent squared plus secant squared is not an identity by itself. It's not. Even if you try to manipulate this guy right here, you're not going to be able to get into tangent squared plus secant squared. So, what do we do? Well, if we can get that identity to just have one of the functions by itself, then we can plug in for that one, right? And it's already got one function by itself. So this identity has secant squared by itself. So I can go ahead and substitute in for secant squared. I can take tangent squared plus 1 and plug it in right here. And so we get tangent squared plus tangent squared plus 1 equals 3. And you really ought to put whatever you plug into an equation, substitute into an equation, you need to put in parentheses. That way, if you need to distribute into those or whatever, that's already set up for you, right? Sometimes the parentheses won't matter, like here. They don't really matter, but it's just a good habit to get into. So combine your two tangent squareds here. Then you can get tangent squared by itself by subtracting 1 and dividing 2. So tangent squared equals 1. And then we can square root both sides. And so tangent theta is equal to plus or minus 1. Don't forget your plus or minus. Okay, so to continue solving, tangent can be positive 1 or it can be negative 1. So if we do a quick quadrant analysis, since the value itself is 1 no matter what, just the sign changes, I'm going to use one set of quadrants to do this. Tangent is positive in quadrant 1 and 3. It's negative in quadrants 2 and 4. So I'm looking for an angle in all 4 quadrants. So what I need now is an angle measure where tangent is just 1. That angle measure is 45 degrees, right? So that becomes your distance from the horizontal. That means that our solutions are 45, 135, you know the drill, 225, and 315. Okay? And so there you go. All right? Next one. Looks like this. So cosine squared equals 1 plus sine squared. Now, in the end, it doesn't really matter which function you substitute in for. This will work. No matter which one you decide to get rid of, as long as you have one function in your equations, right? Now, I can try to use this identity, but if that's like my second equation, I got to get that second equation to where it just equals to where one of the trig functions is by itself, right? In other words, I got to solve for sine squared or solve for cosine squared, and it doesn't really matter which one. Okay? So, whatever, pick your poison, right? Maybe we solve Well, cosine squared is on the side by itself, so maybe we solve this for cosine squared and substitute in. So cosine squared is equal to 1 minus sine squared. I know it's kind of small, but we're going to take 1 minus sine squared and put it in right there. So we get 1 minus sine squared equals 1 plus sine squared. Now, the only trig function that I see that I'm going to try to solve for, which is sine, is being squared. So, get that by itself, right? Add sine squared to both sides. Now you subtract 1, divide by 2, and then square root, square root. So sine theta is going to be equal to 0. So a quick quadrant analysis, sine is 0 here and here. So your solutions become 0, 180, and 360. And we're done. Okay? Next one. Looks like this, right? So first question for you. Can we substitute anything in for sine to the first, right? Just that regular sine. The answer is no, we can't. Not even from here, because that's not sine squared. It's just sine, right? All of these are Pythagorean identities, so everything needs to be squared. Whatever we're going to substitute in for needs to be squared. So we can substitute in for cosine squared. When we do, I've got to get, again, this first identity equal to cosine squared. So again, cosine squared x is equal to 1 minus sine squared x. I'm going to take this and substitute in for that cosine squared x. Now here, the parentheses are going to make a huge difference, so make sure you include them. Right? Now distribute the 2. So we go 2 minus 2 sine squared x minus sine x minus 1 is equal to 0. Now, the equation's equal to 0, but it's not quite in standard form. I want this sine squared to be first. So go negative 2 sine squared x. Then I need the sine to come next. And then I'm going to combine these two like terms. 2 minus 1 is positive 1, so I'm going to move it to the end. Okay, now, we can't just get sine squared by itself and square root both sides because there's just a regular sign in there and it's going to get in the way. So we are going to have to factor this down. But we don't ever factor when the first term is negative, right? So I'm going to divide everything by negative 1, including this 0, which basically just switches all of the signs. Now I can factor this down into something that's a bit more meaningful. Right? 2 sine squared factors into 2 sine x and sine x. And then to find factors of negative 1 that will help us get smiles of positive 1, we can go plus 1 here, minus 1 here. And so our 2 factors we're going to set equal to 0, just like we were doing last time. Now we're going to add 1, divide by 2. Then we're going to subtract 1. And we start thinking about angles that are going to make this happen. So sine of x equals negative 1 is a little bit easier. Where on the unit circle is sine negative 1? That answer is down here. So x is going to be 270. Now the other one, where is sine positive? Sine is positive in 1 and 2. I need a value, I need an angle whose sine value is a half, and that's 30. So our distance from the horizontal is 30, which means that in quadrant 1, that's one of our solutions. In quadrant 2, we subtract from 180, and so we get 150, and there are your solutions. Okay? A little bit more labor intensive, but I don't know if it's very hard or not, right? Okay. Now, you try. Try this one. Stop the video, start it back up. I'll show you what you should get in just a second. Okay. There you go. We're going to plug 1 minus cosine squared in for sine squared, and then simplify down. Again, I want to get to where I've got cosine squared up front, and it's positive. So you can see how it's factored down and solved from there, right? So if you didn't get that, make sure you find me, and we'll walk through it together and see what happened, okay? Another one for you to try, and we'll take a look at a couple more. And so you should have gotten this, 30, 150, and 90. Okay? So take a look at how that was solved. Again, if you have any questions, just come find me and we'll walk through it together. Okay? Oh, I'm a little bit too far. So next one is like this, cosecant squared. That should be cosecant squared theta. There's a typo there. Minus 2 cotangent theta equals 4. All right, two different trig functions. I want to get down to one. I cannot plug in for cotangent theta because it's not squared. So I got to plug in for cosecant theta. And I'm going to put 1 plus cotangent squared in its place. Okay. Do some rearranging so it's in standard form. We go cotangent squared theta up front minus 2 cotangent theta, and then I got to subtract 4 from both sides. 1 minus 4 is negative 3. Put that at the end. Okay? Got to make sure that your equation's equal to 0 before we can go solve. Now we want to factor. So cotangent theta here, cotangent theta here. And then I got to go minus 3 plus 1 in order to get our smiles to add to negative 2. Now, take your factors, set them equal to 0. And you're going to get cotangent theta equals negative 1 and cotangent theta equals 3. Now, cotangent theta being negative 1 is actually a unit circle value. So we can do a quick analysis. If I need cotangent to be negative 1, then that's the same thing as saying I need tangent to be negative 1, right? Why is that? Because remember, cotangent is just the reciprocal of tangent. So if I flip over the value for cotangent, if I flip over the value of tangent, I need to get the value of cotangent. Well, if you flip negative 1 over, you still get negative 1. So I need to know where tangent is going to be negative, which is in quadrant 2 and 4. And I need the angle measure where tangent is 1, and that's 45. So that means that we are 45 degrees from the horizontal in quadrant 2 and 4, which puts me at 135 and 315. So there's 2 of our solutions. Okay, now the other one is cotangent theta equals 3. Which is not a value on the unit circle. So now we have to remember how to get this out of our calculator, right? Remember that cotangent is 1 over tangent, right? But I want to be able to type inverse tangent into my calculator. I can't type inverse cotangent. So in order to keep the tangent out of the denominator, instead of flipping over the cotangent, I'm going to flip over the value and make it 1/3, and then inverse that. So really what I need to do is inverse tangent 1/3. Now, I have to relate back to tangent in terms of our quadrant analysis, because that's what I'm going to use in my calculator. So again, where is tangent positive? It's positive 1/3, right? Tangent is positive in quadrant 1 and quadrant 3. So if I hit inverse tangent of 1 divided by 3, I get 18.4. which becomes my distance from the horizontal. Which means that two more solutions, I get 18.4, and then for quadrant 3, I got to add that to 180, and so we get 198.4. So those are solutions as well. Okay? So just kind of thinking back to Unit 1, how we get the value, how we get an angle out of a cotangent. And the same would be the true for secant and cosecant. We'd have to flip the value over and then do inverse cosine, inverse sine, whichever one it goes with. Okay? All right. So here's one for you to try. Give it a shot. See if you can't remember how to get this, your angle measures out of your calculator. Okay? But stop the video, work through it, and then if you have any questions, come find me. Okay, did you get this? So, we replaced the tangent squared with secant squared minus 1. And we got to rewrite the secant squared plus secant minus 2, and then factor that, and you see how it's factored. So, in one instance, secant needs to be equal to 1, and secant needs to be equal to negative 2 in the other factor. And you can see how secant was rewritten as cosine, and then you have to flip the value over. Of course, in that right-hand equation, if you flip 1 over, you just get 1. But in this other one, if you flip negative 2 over, you get negative 1/2. Then you can inverse cosine, or actually these are both unit circle values, so you don't have to use your calculator. Just start doing your quadrant analysis and coming up with your angles from there. Okay? So, bottom line is, if you're using secant, cosecant, or cotangent, just change it over to one of the original 3's that it goes with, and flip over the value. Okay? All right. Homework's out in Canvas. Give it a shot. Bring your questions with you next time.